right. Welcome back. Hope you're doing well. Hope you're able to keep up with everything. Today we're going to be talking about solving equations and inequalities. I broke this up into two parts. Okay. Part one, just basic, solving an equation, solving for an unknown, just kind of refreshing our minds as to how to do that. The second part, we're going to start talking about, I believe it's going to be some inequalities mixed in with the absolute value mixed in with the inequalities. Okay, so something you haven't done in a long time. So let's go ahead and get started. We already used properties of real numbers to evaluate expressions. Okay, in the homework, you've done that. Now we're going to translate verbal expressions into algebraic ones. Okay, and vice versa. And then for the last part, we're going to solve equations using properties of equality. Okay, that's for today's objective. So let's get started. Once again, pause the video whenever you need to. We have A and B. We're going to go ahead and write this sentence into an algebraic expression. The quotient of 5 is less than a number and 12. Okay? Think about that. How would I write that as an expression? Well, a big word that pops out is quotient. Quotient, okay, we're talking about a fraction. Okay? And right after the word quotient, whatever they list after that word is going to be in our numerator. Okay? So in the numerator, we have 5 is less than a number. Now, I don't know what that number is. Common one is x. You can use x if you'd like. Or you can use any variable. So 5 less than a number. So what would that look like? Well, less than, we're talking about subtraction. Okay? So it's going to be x minus 5. Right? Not reverse. It's not 5 minus x. Remember, it's 5 less than a number. If you flip it, you're saying a number less than 5. See how it kind of switches it? And I think that's the hardest thing when you're translating a subtraction expression into this. So it's x minus 5. After that, we have the word and 12. That and is separating numerator and denominator, so it's going to be over 12. Okay? Next, the square of a number decreased by the product of 5 and a number. Now, I don't know what the number is, so I'm just going to go ahead and use x. Square means, well, there's an exponent involved. So square of a number, there's the first part, decreased by. Now, decreased means subtraction, right? The product of 5 and a number. Product means multiplication. 5 and the number. 5 and the number. Okay, so this is the product part. This is the decreased. And this is the square of a number. So that's the whole expression broken down. Okay? This does take a little bit of practice, but when you do a word-by-word translation, you just have to go back into that mathematical vocabulary from earlier grades and piece it all together. Okay, so here's the two answers. Okay, let's do the opposite. Let's use this expression and let's write some words. Okay, we're going to do the reverse now. So g minus 5 equals negative 2. Okay? So what's another way for subtraction? Now some people might say g minus 5 equals negative 2. Not a bad sentence, but we can do it a little bit better, right? Another word for subtraction is difference. So let's use difference instead. So here's what we're going to write. The difference of a number, because we don't know what g is, right? It's just a number. So this is g. The difference, that's subtraction, the difference of a number and 5 is negative 2. Remember, is represents the equal sign. Okay? If you think back to a long time ago when you were doing these types of problems, is represents the equal sign. So the difference of a number and 5, okay, is -2. So there's one way to write this sentence, okay? Now, if you come up with a different way, just like I said, please reach out to me. I'd be glad to check it for you. A lot of ways of writing this. Part B, write a verbal sentence for this. 2c equals c minus 4, okay? So we used difference already for subtraction. Let's use it again, okay? So this part of the expression, I'm going to say difference. This part is multiplying, so let's use the word product for it, okay? So we can say 2, well, not really. Let me think about that. We could say the product of 2 and a number is equal to the difference of a number and 4. Okay? So the product of 2 and a number, that's 2c that we just did, is equal, there's your equal sign. So I switched the words out a little bit. The difference, which is subtraction, of a number and 4. So that's the c minus 4 part. See how I kind of break everything down? A lot of ways of writing this, so you could have said something different. But that's just using just different verbiage to different words to this type of thing, okay? So a little bit of a review. Oh, there you go. And I'm going to apologize. Something went bump with the PowerPoint. If you don't see that 2 there, I didn't mimic that in my writing, okay? I'm not sure what happened. But if you need to, you could say squared, that numbered squared, okay? That's the only difference. If the 2 wasn't there, I wouldn't put squared. Okay, I believe this is on your reference sheet, okay? These are the properties of equality. The reflexive property, if you remember back in geometry, reflexive means that they're congruent to each other, okay? It's the same segment congruent to itself. Okay, same thing here. B plus 12 is equal to B plus 12. That's the reflexive property, okay? Symmetric means I can take the expression and flip it. Value doesn't change. So once again, if you look at this example, they wrote the equation this way, and look what they did afterwards. They flipped it. Now, does that mean that I'm going to get a different answer? No. I'm still going to follow the same rules of algebra. Transitive, we used this a lot in geometry when we did proofs, if you remember that. Not to bring up bad memories. Some people liked proofs. You know, I enjoy it. It's not a bad thing. I know some people didn't like it. Transitive means if 2 elements are equal to the same number or value, then they must be equal. Okay, and you talked about this in Algebra 1, and we talked about this a lot in geometry. So if you take a look, you see how these 2 equations are both equal to 48? If that's the case, then the equations themselves must equal. Okay, and we're going to use that a lot down the road. So that's going to become a common thing for us, especially when we get to like systems and different things like that. Last part, substitution. If I know what a number is, I can plug it into the equation and solve. And we've done substitution before. Okay? So let's practice. Name the property. Okay? So for the first one, 9 equals x, then x equals 9. I didn't change anything. So what would it be? Okay? The answer is that's going to be the symmetric property. Okay? It doesn't really matter how I order it, it's still the same value. Okay, symmetric. I think if I did this, yes, I did keep it. Okay, there we go. There's our answer. Next one. See how it's the same equation, equal to each other? Nothing's changed. So that one's going to be the reflexive property. Okay? actually going to do some problem solving, which is pretty cool. So just a basic multi-step equation. Once again, just get you back into the rhythm of things. So 53 equals 3 times the quantity of y minus 2 times the quantity of 3 minus 1. There we go. Okay? And once again, I would encourage you to try this out first before you see me solve it. See if we get the same answer. I hope we do get the same answer. So my first step would be to take care of the distribution that's going on here. So this 3, I carried into the parentheses, and this negative 2, I'm going to carry into parentheses. I'm going to carry that negative 2 in there, the whole thing. So 53 equals 3y minus 6 minus 6y plus 2. Okay? Negative numbers, always an area of weakness. I make that mistake too when I start solving these things. I forget the negative. So just be careful. Okay, combine some like terms. I have a 3y and a negative 6y I'll combine. So I get negative 3y. And then I got a negative 6 and a 2 I'll combine to make negative 4. We're going to add 4 to the other side to keep everything equal, right? So 57 equals negative 3y. And then last step to finish it, divide both sides by negative 3. Okay, so y would be equal to negative 19. Now, how do we check our work? If we plug negative 19 back into this equation, we should get 53. And we do. I always encourage you to check it out yourself. Okay? Any questions? You don't have to be quiet. You can tell me. Do you have a question? Okay, well, you missed your mark. Hopefully you didn't have any questions. And obviously, I'm just kidding. Very bad joke, I know. Okay, next up. Okay, let's rearrange a formula. This is used a lot in mathematics and in your science classes too. Okay, so to find the surface area of a cone, they give you the formula there. L is the slant height of the cone, R is the radius of the base. They want you to solve for L. Now there's multiple ways of doing this. How I do it might differ from you, but we're going to get to the same answer. Okay? So let's start with the basic formula. Okay? We want to solve for L. So here's what I would do. This is where I think it'd be easier. This whole thing's a number, right? I don't know what it is yet because I don't know what R is, but it's a number. And if this was a number, how do I undo addition? Subtraction. So I'm going to go ahead and subtract that number to both sides. So just remember, in your mind, you have to not think of it as like variables in a way. You have to think of it as, that's just a number that I need to get rid of. L, I want to stay where it's at right now. So surface area minus pi r squared equals pi, radius, and then the slant height. I'm trying to solve for L, right? That's the goal. I'm almost done. To get L by itself, it's being multiplied by pi times the radius. So to undo multiplication, we divide. So I'm going to divide both sides by pi times r. So surface area minus pi r squared divided by pi, r equals L. Okay, there's my final answer for you. Okay. Now, another method, you could factor out pi r from both of them. I'll just show you real quick. Just another method. But if I factor pi and r out of both of them, okay, this is what I'm left with. All right. And then what I could do is divide those sides and then subtract r. Now, when I do it in that fashion, I'm going to have uncommon denominators here that you're going to have to combine. So I'll show you real quick. So I'll divide by pi times r, and then subtract. Oops. You're going to say, hey, Mr. McCullough, those don't look the same right now. And you're right, they don't look the same. I have to combine these, find a common denominator, and go from there. So these are equivalent. This is just a combined version of this. Okay? So, when is it better to choose one method? It depends on the problem. It really does. If it gets too complicated, it might be easier to factor something and just look at what's left. But this wasn't too complicated where we can just work on it. Okay? All righty. I think it's your turn. And I think we're getting close to the end here. So we have a formula for a perimeter. It's twice the length plus twice the width. Okay? And they want you to solve the formula for W. And it has to be one of those options. So while I'm erasing this, pause the video and try it out. So when I'm looking at these problems, if I'm trying to solve for W, I don't really want to move it. Are there cases that you want to? Possibly. But in this case, if I'm trying to solve for a variable, I want to keep it where it's at. If I keep moving it left or right, I could do an algebra error. I could be making it a lot more complicated. So just for right now, leave it where it's at. This has to go. Now, 2L, twice the length. That's a number. Even though I don't know what L is, it's a number still. And if I'm adding a number, to undo it, I will subtract it to both sides. So perimeter minus twice the length equals 2W. Just like that. Okay? Then for my last step, W is not by itself. I'm going to divide both sides by 2. So the width is equal to P minus 2L divided by 2. Okay, there's my final answer for that guy. So our correct option would be C. Sorry, as you've seen, everything got shifted, but it would be this guy here. Okay? And there we go. That's solving for a variable, and that's a very important math skill to have. Okay? Comes in handy later on down the road. I got 2 problems left, so hang in there. We're almost done. I'm trying to make the video as small as possible. This was like I don't know if it was a state test question or an ACT question, but this came up in some sort of standardized test practice. And I thought, hey, this is probably a good problem to try out. And it's good for equality. Okay? 4g plus 5 equals 4/9. What is the value of 4g minus 2? All right. What is it really asking here? It's kind of weird, isn't it? Weird looking problem. And I'm going to show you a way of solving it. Now, could you solve for g, plug stuff in, and see what happens? Yes, you could. But there's a simpler solution to this. I want this, the 4g plus 5, to look like 4g minus 2. Don't worry about this guy. Don't worry about the 4/9 yet. How can I transform this into this? Well, I could do a little subtraction, right? If I subtract 7 from this guy, don't I get -2? So let's do that. We're trying to make these equations look the same. So the goal, wow, that's not how you spell goal. Goal is for it to look like this. Okay? So to do that, I'm going to subtract 7 from both sides, because once again, got to keep equality. So 4g minus 2 equals 4/9 minus 7. Hey, look, I got it. This looks like this now, right? So what's it equal to? This guy. But it's not one of the options. So what do I have to do? Well, find some common denominators, right? I think this one would be 9. So 4/9 we'll leave as is. Multiply top and bottom by 9. So we get 63 over 9. Okay. 4 minus 63 would be -59 over over 9. There's my answer. Okay? A little bit easier than, solving for G and then plugging it into that guy. Could take a little bit more time. In this case, you get through a little bit quicker. So like I said, the goal is, how do I make this look like this? And then follow the normal rules of algebra, and you get that value. Okay? Seeing this firsthand, I don't know what it wants. At least that's how I felt when I first encountered these problems. Okay, last one. Once again, I pause the video as I'm erasing, so that way you can try it out yourself. So 2x plus 6 equals negative 3. What's the value of 2x minus 3? What does that equation equal to? Well, I want this to look like this. The 2x I'm leaving alone, but how do I get 6 to be negative 3? What can I do? I think I have to subtract 9. Don't you think? If I subtract 9, look what happens. 2x minus 3 equals negative 12. Hey, look. I got the equation. And it would be equal to negative 12, so it's going to be option or choice D as our final answer. Okay? Alrighty. And that's it. Okay? So that's just equation and problem solving. Not too bad. Stay tuned for some practice. Okay? If you have any questions, just let me know, guys. But starting next day or two, we'll start talking about the next set of items. All right? So thanks for watching. Have a good day.